So the question is -5 times that by 8. How am I going to show what -5 looks like? So this is what -5 is. -5 times 1, -5 times 2, -5 times 3, -5 times 4, -5 times 5, -5 times 6, -5 times 7, and -5 times 8. And that's how you do -5 times 8 on the abacus. That's it. All right. So what are we doing? What we're going to be doing is we're going to be doing some adding and subtracting. The first thing we're going to do is we're going to understand how to read the abacus. Now, this was kind of a interesting question because you can't really do negative on the abacus. Just so you know, I'm just saying. So the first thing we're going to do is we're going to understand how to look at the abacus. So we have the top beads and we have the bottom beads. We have the top beads. These are the top beads. These are the top beads. Depending on where the horizontal bar is, right? This is all the bottom beads. The bottom beads is anything underneath the horizontal bar. So what does that mean? This means that these are all the value of 1. These are all the value of 1, and this is all the value of 5. When we're counting, we count 0. We have 0, 1, 2, 3, 4. Notice I said 1, 2, 3, 4, not -1, -2, -3, -4. We don't do more than just what we have, right? Anyways, so what are we doing? We are learning how to read the abacus. So we have 4. So when we do 4, right, we do 1, 1, 1, no, 1. So all of these can be 1, 1, 1, 1, 1, 1. So if I did 2, that would be 2. In comparison with this and this is 2. So when we do 2, this can all be 2. And then we have 3. If you notice, this is 3. 1, 2, 3. And then these are all 2s. In comparison, there's 1 extra, right? Makes sense. So what we're doing is we're just going to look at the abacus and understand how to read it. So then we have all these are 3s, and then we have 4s. These are all 4s. Not, sorry, this is 4. All of these are 3s. So if I did this, now they're all 4s. Hello. I'm not sure. Okay, so then what's after 4? Well, 4 is this, 5. We know what 5 is. Hey, Ghosty! We are learning how to read the abacus right now. And I just started, actually. And that's it. So what we're doing is we're learning how to see how to read 5. 5 looks like this. All the top beat is 5. That's 5. 5, 5, 5, 5, 5, 5. No, that's not 5. This is 5. This is the only one that's 5. But if I did this, these are all 5s. Yeah? I'm really OG in here. You are now. Yeah. It's been a little bit, hasn't it? Is it too easy for you? Yeah, I understand. All right, so this is 6. This is 6. When we have 5, 6, that's what 6 looks like. And then we did 6. These are all 6s. I don't know if you were here. I don't know. Oh, I was gonna say I don't know if you heard all of my all of my sound bits. Okay, Ghosty, I'll see you later. Have a good one, and I will hope to see you in my next live. Whoa, whoa, yeah. Okay, cool. So, what are we doing? We are what? Gosh. Okay. So after 6, we have 6. This is 6, and then we have 7. Oh, okay. I'll see you later. We have 7, and then after 7, what are we doing? I'm sorry. We have 7. So when we do this, this is 7, 7, 7, 7, 7, 7, and then we have 8. Right? 8 is this. 8. That's what 8 looks like. 8. So these are all 7s, and now we have 8. And when we look, we have 8, 8, 8, 8, 8, 8, 8. And then we have 9. Well, how do I know this is 9? Because we have 5, 6, 7, 8, 9. Now, when we look at it, this is 8, this is 9. In comparison, we're just adding one more extra beat. That's it. So when I put all of this, this is all 9s. Yeah, makes sense? Anybody have any abacus questions? Did I go to college? Yes, I did. Are you Japanese? No, I am not. Okay. Anything about abacus? You don't need to be Japanese to learn abacus. All right, so let's go again. Let's do a review. We're going to do 1, 2, 3, 4, and then 5. All the top beads, anytime the beads are touching this horizontal bar, this is being counted. So we have 5 and 6. When I do 0, and then we have 6. If I did 0, and then I have 7. I do 0, and then I have 8. 0, right? None of the beads are touching. And then we have 9. I think I counted that right? So then you might be wondering, well, what about 10? 10 looks like this. 10 is a 0 and a 1. So that's what it looks like. 1 and 0. I'd love to learn how to use it. What is this? What is this? Deftones. Oh, I love the Deftones. But they're not losers. Okay. What is this? This is an abacus, and I'm so happy, Kimber, that you wanted to learn. So what we're doing is we're counting how to read. We're learning to read the abacus. So this is 10. When I count, we can do 20. Now we can count by tens. 10, 20, 30, 40, and then 50, 60, 70, 80, 90, and then 100. Make sense? Hello, Emmy. Hello. How are you today? Thank you so much for joining my live. All right. Whew. So what are we doing? We're learning to read the abacus. So the first thing we're going to do is let's say we do 2025. When we're looking at this is the year of 2025. What is it used for? It's used for counting. We use abacus to do some arithmetic. We're doing adding, subtracting, multiplication, and we can do division. But I don't know if we're going to get to division. We will see. But the first thing we're going to do is we're going to understand how to read the abacus. After we read the abacus, we're going to learn how to add on the abacus. Godiva! Aw, start from the beginning, please. Aw, I am from the beginning. So what we're doing is we're reading the abacus. So when we read it, 1, 2, 3, 4, right? Godiva, does that make sense? All the beads, right, touching this horizontal bar is being counted. And then we have 5. All the top beads is the value of 5. So we have 5, 5, 5, 5, 5, 5, 5, 5. Those are all 5. When we have 6, we have 5, right? We have 1, and then we add the 5. Now we have 6. We have 2, add the 1, now we have 7. We have 3, 1, 2, 3, we add the 5, now we have 8. We have 4, 1, 2, 3, 4, and we add the 5, now we have 9. Now this is what I was talking about right here, and you're right, Godiva, I was not in the beginning, but this is the beginning now. We're doing a review. So when we do the review, we want to do 1. No, we want to do 10. When we do 10, it's a 1 and a 0. This is not 10. Why? Because it's a value of 5. This is 5 and this is 5. So together, it just makes 55. All right? So we have 10 and then we have 11. Notice that the beads are touching the horizontal bar. This is 11. So 11, 12, 13, 14, and then 15. 15, 16, 17, 18, 19, and then 20, right? When we're looking, we have 21. And now what we can do is we can understand our place values. When we look at it, we have place values. So we have 21. How do I know? Because if you notice, I have these dots on my abacus. This one and this one. Like a Pokemon, I just need to choose. I just need to choose one. So if I choose this one, then all my ones, because this just means a label. This is a label for the ones. So because I labeled this as the ones, and be my ones, my tens, but notice I have no hundreds. And there we go. So when we have hundreds and then no thousands and no 10,000. When I decide to choose this one, when I choose this one over here, now I have a lot more numbers, right? It all depends on what numbers you choose, what numbers you have. So you choose the dot indicator, whatever suits the best for you. So here I would choose this one over here. The reason why is because now I have more numbers, ones, tens, 100, thousands, 10,000. Now I see to put the paper. Oh, good. Yeah, does that make sense, Kimber? So when we're looking also, this is the ones, the decimal place. In the decimal, right, does not sit on a place value. We have our ones, decimal, and then there's the tenths and then the hundreds. We can also make it better. Not make it better. We can also make it bigger. If you notice, this is a 7-column abacus. 1, 2, 3, 4, 5, 6, 7. This is a 7-column abacus. We can use a 13-column abacus. It would use exactly the same. So this is my 13 column. 13 column is exactly the same. The only thing that the difference is that there's just more columns. And because there's more columns, then we have a bigger number. So here's my bigger number. So when I look, I can choose any of these dots to be my indicator. And then I can go all the way up to, I think, trillion. So then, cryptonics. So, welcome back. Welcome back. I missed you. All right. So here, when I want the zero, right? If I want the ones here or the ones here, we can do ones if I choose the ones here. So if you notice, it's grouped every thousands. So we have ones, thousands, millions, billions, and trillions. Right? Does that make sense, Kimber? So when we're looking, it doesn't matter. It just matters like which one you choose to be the ones. And then obviously the next one over will always be the thousands. Hey, strawberry. That's funny. Strawberry. Thank you so much. I like it. I think it's really cool. But we can add, subtract, and multiply and divide. The first thing we're going to do is understand how to read the abacus. Okay, so how are we doing? So the first thing we're going to do is understand it's all about positioning. So if I do this, this is 5. Now what does that mean? Just like this, right? If I line it up, it's 5. The colors here means nothing. My Wi-Fi is good. Okay. Hey, Ami. Amani. Welcome. I would need the paper all the time. No, you wouldn't, Kimber, because you'll get used to it. Once you get used to it, it'll be easy. What an easy question? Oh, you know what? Here, you know what? Let's do this. I have a thing for you. Okay. Let me move my books. Okay. So this is my maze. Here we are. So when we're doing it, you want an easy question. We're going to start here. This is the maze, and this maze is trying to do some bead recognition. Oh, I did this one. I want to do this one. Let's do this one. You start from here. You start from here, and then you find the answer, and then we move around on our abacus. So let's see, Kimber. Hopefully you can see that. How's that? All right. So I have my tens and my ones. If I have my tens, and then I have my ones, what number do we think this is? Is that better? I don't know. There we go. I'm going to stop, and then hopefully it'll stay. All right. What number do we think that is? If I have my tens, I have my ones. When I look at it, hi, yes, it is 49. How do I know? See, you didn't need the you didn't need the placeholder. We have our tens or ones. How do I know it's 49? 4, 1, 2, 3, 4 on the tens, and then we have 9. 5, 6, 7, 8, 9. See, I told you. Easy, easy, easy. So here's my next one. If I have my tens and I have my ones, I have my tens and I have my ones. How's it going, E? So I have my tens and I have my ones. What number do you think that is? Thank you so much, Kimber. I appreciate that. What number do we think that is? I don't even know what I'm looking at for. No. Queen, yes. Ariana, yes. Queen Ariana, yes. 57. How do I know it's 57? Because it's a 5, right? And then 7. 5, 6, 7. 47. Thank you, Valeria. 47 looks like this. Notice the top bead. The top bead will always be 5. So that's 57. Well done. Well done, Kimber. Good, 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 right? So that's the other thing. The abacus also helps to develops the skill for attention to detail. So I have my tens and my ones. I have my tens and then I have my ones. What number do we think this is? Yes. Yes. See, Kimber? Yes. 70, 5, 6, 7, and 3. Thank you, Queen. 1, 2, 3. On the ones, so the blue, yes, the blue will always be the value of 5. So we have 70, 5, 6, 7, and 3. 1, 2, 3. If I add the 5 like that, now we have 8. How do I know? 5, 6, 7, 8. We know 5 plus 3 is equal to 8. So we come down here. Okay, so I have my ones, my tens. So my tens and my ones. What number do you think It is. I would love to get that workbook. Oh, hey. Right now it's available. Not, oh, I have one left in my TikTok shop. If you're looking for it, I do have one in my left. So it is 40. It is 40. Almost, Kimber, because this is what 4 and then 0. 4 and 0. I have one left. And it's right here. Okay, cool. Why is it 40? Because it's a 0 over here. Oh, okay, good, Kimber. For 44, it looks like this. 1, 2, 3, 4, and then 1, 2, 3, 4. Yep, cool. Okay, makes sense, right? Good. So then we have our tens and our ones. So if our tens, and then we have our ones. Oh, you can't see that. Sorry. There we go. We have our tens, and we have our ones. When we look, we have our tens, there's 2 here, and then we have our ones, 5, 6, 7, 8. So what we're doing is we're just learning how to read the abacus. Yes, thank you. 28. Thank you, Kimber. Thank you, Queen. 28. And then we're over here. So then we have our tens, and then this is our ones. What? Didn't we do this already? Why not start on the right? Over here, the reason why. Now, Queen. 74. 74. Hold on, Jackie. So, yeah, 74. Why do I say 74? Because 70, 1, 5, 6, 7, and then 4. 1, 2, 3, 4. 70 looks like this. That's what 70 looks like. Okay, so Jackie, the reason why I'm not over here is because I have a label. This label right here, this is my label. So I'm going to start my ones on my label. We always start on the ones, just as we write. When we write our numbers, it's always going to be ones. So, 74. I'll go over here. There we are. Yeah. So, I mean, it's hard to see, obviously, because in the video, right, you can't see. But if you had your own, you would see that there's actually 2. There's one here and there's one here. Yeah, I can't see it from the video. But just so you know, is that the decimal point? No, it's not a decimal point. It's a label to tell me the ones. So yes, it is 42. How do I know? Because it's 4 and 2. My tens, 1, 2, 3, 4, and my 2, 1, 2 in the ones place. So here we have this number. Does that make sense? Yeah, not a problem, Jackie. So I could choose this one to be my ones, but then it'd be my ones and my tens. So if I did it this, right, that would be my ones and this would be my tens. You could choose here or you could choose here. It just depends on how big the number is. 7, right, Kimber? See, too easy. Too easy. Thank you, Queen. Thank you. And then we have our tens and we have our ones. And sometimes, and I usually am over here because our numbers are actually quite big. So what I want to do is I usually want start from here. 69. Yes, thank you. 69. Yeah, we're okay. So we're going to go to here, and then we have this number. We have our tens and our ones. So our tens and our ones. How about you, Jackie? What number do you think this is? New here. Can you please explain which color and why? 31. See? 31. 31. 1, 2, 3, and then the 1. Thank you, Lionel. An old Chinese seller. Edit? Tweddit? Tweddit? Are you 10? This is no fun. Then leave the room. You don't need to stay here. So here we are. We have our tens and we have our ones. What are we doing? Tens and ones. How's it going? Right? Tens and ones. Toxica. Oh, hold on, Toxica. Hold on just a minute. So what we're doing is we're reading the abacus. We have our tens and our ones and tens. When we look, does this make sense of why this is 4? 1, 2, 3, 4? But it's not 4, it's on the tens. So when we look, oh, there you are. 30. I've seen one of these at Goodwill. I had no clue how to use it. I didn't get it. 40. Yes, it is 40. It is 40. Yes, thank you. Thank you, Queen. Thank you, Lionel. Right? This is 40. How do I know? Because it's 4 and a 0. So when we're looking, toxin. I think it was toxin. I don't know if you're still here. Toxia. Toxica. Vero. Vero. I'll call you Vero if it's okay. So when we look, we have our ones and our tens. When we look at our ones and our tens, right, we can do 0 and 4. When we have 0 and 4, now we have this number, right? When we're looking at it, we have our tens and our ones. This is what number? Okay, good, you're still here. So when we're looking, right, let me just do this. So when we're looking, if I chose here, my 1, 2, 3, 4, because this is 4, right? And then we have 5. The top beat will always be 5. So yes, toxica, toxic, toxica. Whew. Vero. Can I call you Vero, please? Vero, I can say. Toxica. I can't. I don't know why I'm not registering this. I'm not braining Vero. Thank you. Thank you. I appreciate that. I don't know why my brain's not braining right now. All right. So what we're doing is this is 28. How do I know this is 28? Because I have a 2 and I have an 8. 5, 6, 7, 8. The top beat will always be 8. The top beat will always be 5. 28. I'm over here. All right. Oh, that was a little bit. Okay, so, and then I have my tens and my ones. So notice I have my dot here, so this is my tens. Sorry, this is my ones. When I do this, and then I have that. So what number do we have? What are we doing? Vero is, okay, thank you. Hi. The top bead will always be the top bead for, yes, exactly. Yes, Chris. 74. Thank you, Kimber. Thank you, Queen. Thank you for putting me back on track. Yes, 74, because we have 5, 6, 7, and then 4. 1, 2, 3, 4. What's this used for? It's usually teaching kids how to read teaching kids how to count, add and subtract, and multiply and divide. Usually, but lately, since I've been on live, there's been a lot of adults that are very interested with brain gymnastics. So just like how you do jigsaw puzzles, I don't know if you do jigsaw puzzles, but if you do jigsaw puzzles or Sudoku, crossword puzzles, what else? Logical puzzles, anything puzzle like, I'm trying to bring this into the whole. You can use the abacus as brain gymnastics, if that makes sense. 42. Yes, thank you, Queen. It is 42. Why is it 42? Because we have 40, 1, 2, 3, 4 on the tens place, and then we have 2, 1, 2. Usually, it's parents that are involved with their kids, and they want their kids to learn a different way of math. And Abacus really provides a strong foundation for number sense and number fluency. Oh, you guys can't see that. So if I did this, and this is my ones place, this is my 0. My ones, this is my tens. So what? I understand now, right? Oh, thank you. Oh, I thank you. I don't know Sudoku. Kimber, you don't know Sudoku, but now you know the abacus. I'm trying to learn for my toddler. Okay, good. Yeah, if it's okay. Oh yeah, 7. We're at 7. Kimber. But it's like the thing, like trying to understand this, and then you'll see that we're going to be doing some brain gymnastics. Like you're going to be able to see the numbers, and it'll be very easy. But we're practicing right now just to understand what the numbers look like, right? Oh, that's the number. So this is my tens, and this is my ones. My tens and ones. Thank you for your channel. This is so helpful than watching videos. Yeah, thank you. No, I appreciate it. Let me know so we can continue on with like what we're going to do is we're going to start learning how to add and subtract, and you'll see how beneficial it is to learn abacus, especially for the children. And some people would be asking like, why don't we teach this in school? I don't know. I don't know. I don't know. I'm thinking it's because it's Eurocentric, but I think nobody understood it. I don't know. And so abacus has its own vocabulary, and I'm trying to use the mainstream math to talk about abacus because abacus is math and it's not just for enrichment. Yes, 31. Thank you, Kimber. 31. 1, 2, 3, 30, and then 1. 1. That's it. 31. So then we have this number. When we have this number, our tens and our ones, right? We have our tens and our ones. Queen. Yeah, right? Okay, okay. We're done. What's this number? Don't look at me like that, Queen. I think it's fun. Yeah. I gotta get some easy ones, right? Thank you, Kimber. Thank you, Queen. Okay, good. So what did we just do is we just understood how to read the abacus. It was easy. The reason why is because you'll notice that no matter which column you're in, you're always going to get up to 9. So if you see, this is 0. We do 1, we do 1. That's now 11, right? We do 12, or we do 22. We do 23 or 33. We do 24 or 44. Notice what you do is you mimic. Thank you, Chris. Thank you. Can you use a few of the 100 columns? Yes. So if I did this, right, what number would that be? What number would that be? Now, you got to get the zeros. Remember? Not 500, because there's a 4 here. There's a 4. I didn't move these. So these are 4, 4, and then 5. Yes, thank you, Kimber. So it's 544. 500. Every top beat is a value of 5. The 5 and then 1. So Chris said 144. 144 looks like this. 144. The answer that the question I started off with is 544. Right? So what we want to do is we want to make sure we understand it all depends on what beads are touching the horizontal bar. When the beads are touching the horizontal bar, that's what's being counted. So this is 6. So if I do 6, this is not 6. This is actually 60. And then what we have is we have 600. Then we have 6,000. And then this would be 60,000. But notice I don't have any beads here, right? Oh, because the top bead is 5. Yes, exactly. Because the top bead is 5. And it's always going to be 5 no matter what. So if I did this, oh no, if I did this, this is not 10. This is 55. 10 is a 1 and a 0. I don't know why people think that this is 10, but it's interesting. So, but no, this is 10 because it's a 1 and a 0. When we're looking, and then if you notice there's a decimal here, this decimal sits between the place values. So after the decimal, we have our tenths and our hundreds. If you choose one of these dots, right, you can choose this as your ones. This would be your label. So there'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 10. That would be 10. But then you don't have any room for hundreds. Hey, Riley, welcome back. It's late for you. My goodness. My goodness. This is way too late. You're crazy. Okay. So if you notice that if this is my ones, then the next one over will always be thousands. If you can't say, oh, you know what helped me is I listen to podcasts that are there's a podcast that is good for sleeping. Look for podcasts for sleeping. And he's very monotone. Thank you so much for the heart, me, Riley. And he's very monotone and he's very calm. I don't think this is going to help you go to sleep, Riley, unless you think I'm boring. I can't wait to see subtraction. Oh yeah. So let's go into it. Oh, let me continue on with this. So here, what I did was I did a reverse maze. And this reverse maze is I give you the number and you need to color it in. So because I give you the number and you're going to color it in, right? That's what I did here. So if I give you 54, I give you the way the maze is supposed to look. And I'm like, oh, it's already predetermined, but more comforting than anything. Aw, thank you. So here I give you the number 54, and you're gonna color in 50, and then you're gonna color in 4. What? Really? What does that mean? So then I go to the next box because that's what the line goes to. So then here's my next box, and you go to 96, and you have to color in 96. So what it made, the maze. I'm almost. I'm trying to get stuff ready. I'm almost done with the 3 digits. So notice if I have 54, I'm going to color in 54, 96, and then I have 29, and then there is my 29. So then this one, I would have to look for here, 17, I would color that in, 17. Yeah, so that's what this is. And that is my maze. All right, cool. So the next thing we're going to do is we're going to understand how to move the beats. That's where we're going to start learning how to do some adding and subtracting. So we understand how to read the abacus. We're going to go, I can't believe how easy it is. I'm telling you, Kimber, this is way easy. So, the first thing we're going to do is we're going to understand that the abacus is very easy to move. Because the abacus is easy to move, you want to use your left hand to stabilize it. To use your left hand to stabilize it, and you use your right hand to do the calculations. Even if you're left-handed, you can hold it with your left hand, just hold the pencil or whatever with your left hand and you use your right hand to calculate. They say that the calculations happen on your left brain. And so that's why you want to use your right hand. Okay. So the first thing we're going to do is also understand that we will be only using the edges of the beads. So you want to be happy because they're gentle. Be gentle with the abacus, right? Be gentle when you're doing math. Be gentle when you are be happy when you do math. Why? Because you don't want to be aggressive. If you're aggressive, then all your answers will be wrong. Right? And so the other thing is like, say if I have this number, right? Whatever number. I have this number 7 and I need to add something. And if I did this, oh, that didn't work. No, that didn't work. Okay, so if I had this, if this is my answer and I need to add something else, don't do that. Don't flick too hard. Don't flick too hard because then your answers will become wrong. You want to be intentional when you move the beads. So if I had 9, I want to take away 3, right? And now we're doing a little bit of adding and subtracting. So the first thing we're going to do is we're going to understand in abacus world we want to focus on the add in. What we're doing is we're understanding if we have enough. So my question starts with 7. I have 7 here, 5, 6, 7. I want to add the 1. Can I add the 1? Yes, I can add the 1. And all I got to do is move that 1 bead up. That's it. When I move the 1 bead up, I'm done. So my final answer is 8. And then we can go through it again. Let's do 2. When I do 2, again, what I'm going to do is I'm going to realize if I can add the 2. The question is 6. I want to add the 6. My add-in is 2. Can I add the 2? Yes, we can. So we're going to add the 2. So my final answer is 8. And then, right? Thank you, Chris. So then notice we could do it for 3. We have 5. The question is 5. And then we have 3. We want to add 3. Can we do it? Yes, we can add the 3. That's all we're doing. We're just adding a 3. When we move it to the horizontal bar, that's what's being counted. If you take it away, that's being minus. That's we're subtracting. But you could do it in mainstream way, which is count the dots and count the whatever, right? Count the 5 dots and count the 3, which is different on the abacus because on the abacus you can see that this is 8. We already know that this is 8. How do you know? Because the 5, 6, 7, 8, when you look, it's easy to just look and know what the number is. It is very different than mainstream where you have to count it. Like I would have to count that this is 5, 1, 2, 3, 4, 5, and then this is 3, 6, 7, 8, right? So what we're trying to do is understand that in the abacus world, we're focusing on the add-in, not the result. The other thing is every question we've been on has always been the answer 8. Why? Right? We don't memorize the fact family of 8 because that doesn't make sense on the abacus world. And we will start learning fact family, but having fact family of 8 doesn't make sense. So the next thing we're going to do is we're going to do 4. And if we add the 4, it's just adding the whole thing. So if I have the 5 and I add the 4, my final answer is 9. And that's it. So then we do the minus. When you add, you subtract, right? When we have 4 and I want to take away 2, all you got to do is remove it away from the horizontal bar. That's it. That's all you're doing. That's what subtraction is. Subtracting is very easy on the abacus to see because you know you're taking it away. When I have 4, right? When I have 4 and I take away the 3, I just take away these 3 beads. It doesn't matter what 3 beads you take, you just take away 3 beads. So these are the 3 beads you take away. So my final answer is 1. And then we do it again. Here is 9, and I take away 6, take away 3, take away 3. My final answer is 6. That's easy. Yes, it's very easy. You just got to understand how to read the abacus, and that's why I spent a little time understanding how to read the abacus. If I have 3, I'm going to add the 3. When I add the 5, can I do it? Yes, I can. I'm going to add the 5. All I got to do is just add it to my horizontal bar. So my final answer is 8. Now it's the same thing with the 6. 6. If I add the 1, I want to add 6. I'm just bringing these two together. That's what 6 is. If I add the 6 or take away the 6, I add the 6, take away the 6. So you notice if you add it, you could subtract. It's just the reverse. Just like adding, subtracting is the reverse of each other. And same thing with the 7. If I have the 1, I want to add the 7 and I take away the 7. That's it. What if you can? Ooh, good, Kimber. Very good. So we're done with this, right? We're done with that. But then the question is, what happens what happens when there's not enough? There's this 4, right? There is this 4 on the abacus, and I like to know what, I don't know what I'm trying to sing. Okay, so the first thing we're going to do is we're going to understand, what if there's not enough? Okay, that's what it is. Here is my number. If I don't have enough, what am I going to do? We have 3. I want to add the 4. Cannot add the 4. What does that mean? You move the next one. Almost. The 5 almost. So here we have this concept that we're teaching the kids. Plus 4 is equal to 1 plus 4 is equal to 5. Now let me do it differently. Let me put some money out. Here's some pennies. Here's some ones. 1, 2, 3. Right? 1, 2, 3. So the 3 pennies is going to be the same thing as these beads on the abacus. And then I have 4. If I have 4, I have enough, but I only have 5 cents. That makes enough, right? That's enough. So what happens? I'm going to give you my 5 cents, but then I need change. So I'm going to add it to the change, but I need an exchange. So I'm going to take away the 1. Does that make sense? Because I'm adding 4. I have 5 cents. It's enough. So all I got to do is take away the 1. So I'm going to add the 5 and I'm going to take away the 1. So my final answer is 7. What did we just do? We just powered up our concept. We just powered up our concept. Our concept was 4 plus 1 is equal to 5. We could do it again. Let's do it again. Let's do 4. If I have 4, right? If I have 4 beads on my abacus like that. If I have 4 on my abacus, and then I need to add another 4. There's not enough beads to add the 4, but what? I have 5. I'm starting to get it. Yeah, I have the 5. 5 cents. It's just like money. It's just like money. If I give you 5 cents, that's more than enough. But what? But we need to exchange that out. We need to, what do? We have to take away the 1. So then we're left with 8. Does that make sense? Right? Right? The difference is we're constrained. So I'm going to add the 5 and I take away the 1. So my final answer is 8. Now, why is this different? Well, we could do it the regular mainstream way. I can give you a blank piece of paper and you can draw it out. You could do that. Or, and then the sky is really the limit. However, if we started to understand that we take this concept, which we're already learning, right? We're already teaching this. We're already learning this. Now, the question is how do we use it? What we're going to do is we're going to power it up. Let's make some modification. Vero, yes, you're right. It is not about the color. So if I made it like this, it is not about the color, right? Let's do it again. Let's do it again. So if I have 2, I have 2 on my abacus. I have 2 like that. And then I want to add 4. Because I want to add the 4, I only have 5 cents. Because I only have 5 cents, I'm going to give it to you because it's enough. But what happens? What's going to happen is I've given you too much. I need some money back. So I need to take away the 1. So I'm going to give you the 5 and I'm going to take away the 1. We know what? We know that the 5 can help. Hey, Char, welcome back. Welcome back. Right now, we're just doing the adding of the 5. Yep. Does that make sense? So yes, it doesn't matter about the color of the abacus. What matters is the placement of the beads. So when we're looking, right, we can do it again. If I had 3, Kimber, you okay? If I had 3 on my abacus, oh, I can't do it. If I have 3 on my abacus, 1, 2, 3. I have 3 on my abacus. And then what do? I need 4. But I don't have enough. I don't have enough beads, right? I don't have any more pennies. So what am I going to do? I have a nickel. Because I have a nickel, I'm going to give you my nickel, but that's too much. I need to take away 1. So if I have the 5, that's too much. I need to take away the 1. So what are we doing? We're doing substitution. We needed to isolate the variable, then substitute our information. So 4 to add 5 into, yes, Queen, yes. Yes. This is a different way of looking at it, right? So we have this concept 4 plus 1 is equal to 5. Why? Why are we teaching this? I had to, yeah, no, you're perfectly fine, Kimber, because it's a different way of thinking. Because in school, we're always just taught memorize, 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 memorize. But in Abacus, we memorize, but there's a concept here, right? We know that if 5 is too much, we need to take away the 1, right? We can do it again with the 2. I'm sorry, with the 3. If the 3 is too much, the 5 is too much, we need to balance it, right? We're going to isolate the variable and we're going to balance the equation. And then we substitute this information. So what does that mean? Well, let's do it again. Vera, I'm going to change back to the colored one because it's pretty. So here, if I did 4, I have 4 on my abacus. When I have 4 on my abacus, right? 1, 2, 3, 4. And then what happens? I have 5 cents. I don't have any 3 cents. I don't have any 3 cents. So what am I going to do? I'm going to give you my 5 cents. So what do I do, Kimber? What do you think I'm going to do? If I have 5 cents, but you only need 3, what do you think we should do? What is the partner of 3? The partner of 3 is what? 2. Yes, thank you, Queen. Minus the 2. Minus the 2. So I'm going to add the 5. I'm going to take away the 2. I added the 5. Thank you, Char. I'm going to add the 5 and I got to take away the 2. So my final answer, yes, thank you. My final answer is now 7. Yeah, makes sense? Okay, so what are we doing? We're understanding how to utilize this concept. This is a very critical concept. Yes, we can multiply. We want to do multiplication. Let me finish with a little bit of more adding, and then we will get into multiplication. Can you only add it, or do you like multiplication divide? Yes, you can do multiplication and division on the abacus. But let me continue on with this thought. First, we want to go into how to make a 10, if that's okay. Multiplication is fun. So let's figure out how to add a little bit more, if that's okay. So why? Because we only did up to 5. But what happens to carrying on or carrying over or regrouping or borrowing or trading or all those other, how do we make it when there's more than 10? So that's the question, right? When we do that, how do we do it when there's more than 10? When we do more than 10, we need to understand the concepts. So just like we have here, 3 and 2 are pairs, well, we also have pairs here, 2 and 8, 7 and 3, 4 and 6, 1 and 9. What does that all mean? Well, now after learning how to add the 5, right, we can also take away the 5. This is another concept. So this book is all about adding 5. Adding 5 just means, how do I add the 3? So if I have the question here, if I have 8 and I take away the 6, and then I need to add the 3, to add the 3, there's not enough. I need to give you my 5, right? I'm going to give you the 5, but that's too much. So I need to take away the 2. So when we're looking at it, so my final answer is 5, I just follow the path. Just like how we do on the other maze, but now we have to answer questions. And that's what this book is. This book is about solidifying the concept of how to add the 5. After adding the 5, we will learn how to minus the 5. Oh, you know what? But before that, let's take it one step further. Let's see. This is too easy, Lynette. What? Okay, so let's do something like this. Let's do this one instead. Let's do this one. We know this one. What? So instead of doing this, like saying, what do they call it? Friendly numbers. You can add it on the abacus. We have 26. We want to add 30. We want to add 2. When we add 30, how do we add 3? Do you remember how to add the 3? If I have 2 on my abacus, I want to add the 3. To add the 3, I only have 5 cents. I'm going to give you my 3, but that's too much. So I need to take away the 2. So I'm going to take away the 2. So I add the 5 and I take away the 2. And then, thank you, Kimber. Yes, right? And then we are left with 50, and then we have to add the 2. We add the 2. And now we have 58. That's it. So what I just showed you is really simple math, but now we can scale it. We could do it again. Let's do it again. Let's do it again. So we have 13,578. And then what are we going to do? We're going to add 24,311. We add 20, add the 2 Is there enough? Yes, there is enough. We'll add the 2. Can I add the 4? How do I add the 4 here? Is there enough? There's not enough to add the 4. What do I do? To add the 4, what do I do? I need to, thank you, char, plus the 5 minus the 1. And then I want to add the 3. Is there enough? Yes. Add the 3, add the 1, add the 1. So my final answer is 37,889. Thank you. Thank you, Kimber. Right? Does that make sense now? So what we're doing is we're understanding, first we understand the fundamentals, and now we can actually scale it. That's the idea. The idea is to understand the fundamentals. I mean, it's really easy, but once you know the fundamentals, it is now easier to scale. Okay. So that's about adding the 5. And then the next one is to minus the 5. Minus the 5 is the same, but just the opposite. What is this called? This is called an abacus, a soroban. The one I'm doing is called a soroban. Soroban. Yep. So it's a soroban abacus. It's a Japanese abacus. There are other types of abacus. The in preschool or in kindergarten, there's a 10 bead. That's also an abacus, but that's a Russian abacus. This one is a soroban. It's a Japanese abacus because Japanese people made it more efficient. Okay, so so what we're going to do is we're going to minus the 5. What does that mean? Well, it's just like we added the 5. Now we have to take away the 5. We have the 4. The question is 8. When I have 8 on my abacus, now we know we want to minus the 4. When I minus the 4, I want to minus the 5 plus the 1. So my final answer is 4. What's the difference between... What's the difference? The extra beads. I don't have an example of the Russian abacus, but I do have an example of a Chinese abacus. So this is a Chinese abacus. It has two beads on top and 5 beads on the bottom, whereas the Japanese abacus has 1 bead on top and 4 beads on the bottom. And when we can count 1, 2, 3, 4, 5, and then because we have 5, we have to trade it in to here. Now this is 5. Abacus on the soroban, we have 1, 2, 3, 4. We don't need to trade it in. We know that we're just going to do that, and that would be 5. Then we have 6, 7, 8, 9, 10. Again, because we have 5, we're going to trade it in, and we add the 5 up here. 5 plus 5 on the one column is 10. Because we have 10, we're going to trade that in, and we add the 10 here. This one, we have 5, 6, 7, 8, 9, and because there's 10, now I can add the 10 here. There'll be a 1 and a 0. I was just looking at my abacus today. The problem with the abacus is that you can't see it upside down because of gravity. Vic, that's so funny. Cool 5. Can you explain arithmetic in basic terms? I'm not sure what that means. What does it mean by basic terms? I mean, I think that's what I'm doing. I'm not sure what that means. Is it adding and subtracting? That's all it is. Hey, Josh! So when we're looking at it, right, what we just did is we understand how to take away the 4. Does that make sense? And then we could do it again. We have 16. We have 16 on the abacus. I want to take away 4. There's not enough to take away the 4. We know to minus the 5 plus the 1. So what is it doing? Minus the 5 plus the 1. And our final answer is 12. Right? So when we added, you notice when we add the 5 minus the 1. When we subtract, we minus the 5 and plus the 1, right? Thank you, Char. So what happens is we're understanding that we're not using a different strategy to minus. We're using the same thing, just reverse. So that's the versatility of understanding and compounding our knowledge. We're compounding our information. So we know how to minus the 3. What are the huge ones like the big what are the huge ones like the big ones that have a lot of things on the bottom and the top? This one? This one is this one or the other one? The other one, if it's another one of this, it has 10 beads across. That's what you call a Russian abacus, I believe. There's another one I found, which is a 9 bead. I don't even know how to use that one. That's like crazy. I don't know how to use a 9 bead abacus. I know there's one with nine. Yeah. So there would be like something like this. No, 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 no. Something like this. Yeah, something like this. It's got like 5 beads on top. Yeah. Oh, the 5 beads on top and five, and it's like this. If it's horizontal, that's what you call the Russian abacus. And the Russian abacus, it without the beads, is just by ones. So one, two, three, four. Yeah, yeah, uh, yeah. But if it's on top and bottom, then I'm not sure. The top and bottom one, I found that there's a 9 bead abacus, but I don't know how to use that. Deceptive. Love this, by the way. I don't know deceptive. You're kind of deceptive. I'm not sure if you really. How do I do fractions? Fractions is just another way of doing division. That's all it is. So as long as you know how to do division, you know how to do fractions, if that makes sense. Fractions is just a concept, really, if you think about it. All right. So deceptive. That's funny. All right. Um, so again, we're going to continue on with this when we do 7. So when we have 7, right? We have 7 and we want to take away the 3. Again, minus the 3 is minus the 5 plus the 2. It is 11 p.m. Pacific Standard Time right now. We are midnight mathing right now. Midnight math. So we have what? There we go. We do 16. We have 1 and 6. And we want to take away the 3. To take away the 3, what do? We minus the 3 is what? We don't have enough to minus the 3, so we're going to have to take away the 5 and plus the 2. Take away the 5 plus the 2. My final answer is 13. We love midnight math. Char. Ah, I hope your day progressed well. Thank you, Nansoon. Thank you. It did. In the beginning of my morning, my early afternoon live, it was a little hairy, but then everybody started coming. It was pretty cool. How is this 13? How? 1, 3. 1, 3. Ones, 1, 2, 3. Tens, 1. So it's 13. 4 looks like that. This will always be 4. This is 4. This is 4. I have the same. It's kind of longer. Oh, math, not mathing. I have the same kind, but just longer. Oh, so you have this one, which is the 13 column one, yeah? Yeah? So the 13 column one worked exactly the same. Yeah, yeah. Oh, yeah, yeah. 13 is good. I think 13 is a good size. We only use the abacus in passing. This is fascinating. Oh, thank you, Joel. Yeah. Josh, does that make sense? Right? 13. So if we did 14, that's what, 14? I'm going to teach my daughter. Yay, queen. Good job. Yeah, you should. You should. If you don't mind me asking, I just like to know. I like to know like how old the kids are. Yeah, right? Fairy Mary used the abacus. Soul. They used a abacus like as well. It was an abacus like. They were doing abacus. What else? There was a 4 months. You Yeah, a little young, but you can have them in front of her, and then she could just touch it and play with it like a little car. And then as they move it, right? There's this one kid I saw, and they just put the guitar in front of him, and he just kept touching and playing. But then they did it off, and then as he progressed, he was able to play and play and play and play and play, and he was so good. So I have time to teach her. Yeah. Okay. Yes, the blue ones count as 5. Yes, exactly. We actually call it the top bead. The top bead is a value of 5. So these are all 5s. Yeah, some people get stuck on the color, but the color doesn't mean anything. It's just about the side, the positioning of the top. So when we're looking, we have this. This is 5 and this is 5. So because the 5 is touching the horizontal bar, right? This is counted. Children learn this easily. Yeah. Yeah, my kids learned it pretty quick. But it took a little time to like to get for me to get to where they are. So this is six, this is six, this is seven, this is seven, eight, eight, nine, nine. Okay, so okay, we're gonna continue on. And it's just a bunch of like going through these questions and just understanding. If only schools thought this. Yeah, that's interesting. Like I don't know why we have all these other manipulatives, right? We have counting bears, we have sticks and rods and dots and everything. And so it's interesting that they don't learn how to use the abacus because I think an abacus is a little bit more manageable, right? You can't really eat it and stuff it in your nose. You can't chew on it or throw it away. Well, you could throw it away, but you won't lose the pieces. So as older folks can learn, it's fun. Yeah, I have a lot of people that wanting to learn to use the abacus and to keep their brain active because we don't do a lot of active thinking. And so this would be like brain gymnastics. And that was the one thing, like, that's why I think I really gravitate to Sudoku. And I don't like crossword puzzles, but I like jigsaw puzzles. Did I learn abacus growing up? No, I didn't. I didn't. Josh, I didn't learn abacus when I was young. I actually learned it when I was before I had kids, because my dad decided to open up a learning center and told my brother and I that we had to learn it. And I was like, "What is this stupid thing? Why are we here?" But as I started going down this abacus journey, I realized that this is way better than what I had to learn when I was a kid. Because when I was a kid, we had to memorize everything, right? We had to memorize like our doubles, and then now they have like extra special strategies: double plus two, double minus one, blah blah blah. But in Abacus, it's really quite easy because you could see the numbers. Like if I want to do 2 plus 2, I know I have 2. If I want to do 4 plus 4, I know 4, and then I know I'm going to bring down this 5 because that would be adding 4. So what I need to know is I need to remember the formulas. The formulas are really based on how to make a 5 and how to make a 10. Yeah. Oh, Minesweeper. I love Minesweeper. Did Kumon? I did Kumon. I don't think they use that. No, Kumon had their own worksheets, but they never taught abacus. They just taught what regular mainstream math did, and they were just talking about like really just memorizing, memorizing, memorizing. Whereas on the abacus, it's a lot about conceptually understanding. When I don't have enough, what can I do? And it provides critical thinking. So here we can do minus the two, right? And again, we're going to focus on the add-in, right? We focus on the add-in. When we focus on the add-in, I want to do six. Six on my abacus. Notice I don't have a two. I cannot take away a two. So if I cannot take away a two, what do? I just need to take away the five and add the three. And then I have that set. So it is truly did how difficult is it to pick up learning multiplication and division? Multiplication and division is not difficult just as long as you have the foundation. So the biggest thing is understanding your fundamentals. Once you know the fundamentals, then you add an extra skill, which is multiplication, which we can do multiplication. I'll show you. I just want to go through understanding how to add the 10, and then we can go into multiplication if that's okay. So if this is okay, if everybody's okay here, then we'll go further if that's okay. Yeah? Okay, so we're okay with this. We're okay with the -5. I want to make sure. I mean, there's only 10 of us talking, but there's 70 people here. I didn't believe there's so many people here. But anyways, okay. So let's continue on with the adding of the 10. Adding of the 10 is really easy. Now the reason why is this is what we call what? Carrying on deceptive. Deceptive. All right. Now, adding of the 10, what does that mean? Adding of the 10, just like we talked about it in school, right? We talked about friendly numbers. We talked about fact family. Fact family, 8 and 2. Let's do 8 and 2. When we do 8 and 2, when we do 8 and 2, I should really label this. Okay, here is my abacus and here is my number. We know what 7 looks like, so I'm going to add 7, right? 5, 6, 7. I want to add the 8, but notice because I add the 8, I don't have enough beats to add the 8. Well, guess what? Guess what? Same thing. I have a dime. If I have a dime, I'm going to give you my dime. But what happens? That's too much. What is the partner of 8. Does anybody know? Bueller? Bueller? What is the partner of 8? What's the pair? Thank you. -2. Thank you. Plus the 10, and we're going to take away the 2. Thank you, Queen. So what we're doing is, then my final answer is 15. Thank you, Eve. Welcome back. Welcome back. Thank you, Josh, for the garland heart. Thank you so much. So when we're looking at it, now what did we just do? We understood that we had a concept and we made it better. What did we do? So it's the same thing here. Let's do it again. When we do it again, I have 4. I have 4 on my abacus, right? I have 4. And I want to add the 8. Guess what? I have 10 cents. 10 cents. What is this? This is where we do regrouping in mainstream math. When we regroup, we're going to add the 10. So I'm going to add my 10, and I'm going to take away the 2. And I take away the 2. So my final answer is now 12. Oh, you couldn't see that, but that's okay. Make sense? So we could do it again. So notice what we're doing is we're focusing on the add-in. We're not focusing on the result. The result is all going to be the same. Everybody wants to be happy, right? But what we want to do is we want to understand the journey. The journey is what matters. It is what we're trying to add. And because we're trying to do that, it will be more versatile. So the same thing with the 9. If I had 9, right? If I had 9 and I want to add 8, it's the same thing. I want to add the 10. I have 9. I want to add the 10. I'm sorry, I want to add the 8. Because I add the 8, I want to add the 10. Just like Eve said, I want to take away the 2, just like what Queen said. So all I got to do is just take away the 2, right? I'm just taking away the 2. I add the 10, and I take away the 2. So my final answer is 17. Yeah? Does that make sense? Okay. Yeah? So, great. And it happens again, and we could do it again and again and again with all the other numbers, as long as we know the pairs. So we can do it again with the 7. When we do it again with the 7, let's do 9. We do 9, our pair is 3. So we're going to plus the 10. What are we going to do? We're going to add the 7. We're going to plus the 10. That's too much. And we're going to take away the 3. My final answer is now 6. Thank you. Thank you, Char. Okay. So that's it. You know how to do all of this, then you know how to add and subtract at scale. And that's it. Okay, so now we can do multiplication. Okay, I guess we're ready for muscle multiplication. We better do some multiplication before I get tired. Okay. Let's do that. Let's do some multiplication. I was getting some multiplications ready. Okay. I've got questions. All right. The first thing we're going to do is we're going to understand. You guys are so funny. The first thing we're going to do is we're going to understand what are we trying to do. We're going to do multiplication. Now, in a multiplication, we call this thing distributive property. Distributive property is what? Is an algebraic terminology. Because this is an algebraic terminology, this is what we're going to do. What does that mean? Distributive property means we're going to do this number, and then we're going to do that number. That's what that means. Okay? Yeah? So the first thing we're going to do is we're going to do 5 times 2. So what do you do? 5 times 2 is equal to 10. So, I'm sorry, I forgot to count. 1, 2, 3, 4. We need to know where to put our answer. So we know 1, 2, 3, 4. Remember, our ones is over here. So if you count from here, we're going to end up here somewhere. Because when we look, you'll see. So 5 times 2 is 10. Add my 1, add my 0. 5 times 4 is equal to 20. Add my 2, add my 0. Then we're done with the 5, right? The next thing we're going to do is the 8 times 2. 8 times 2. 8 times 2 is equal to 16. Is there enough? Oh, sorry, I have to recount. 1, 2, 3. So I'm over here. Add 16 because that's 8 times 2. I had 1. I add 6. And then what's my next one? 8 times 4 is 32. Add 3, add the 2. Hey, don't forget to smile. I'm doing well. Thank you so much. Thank you so much. Wait, why start at 3? Oh, the reason why? Oh, because we're done with the 5. When we're done with the 5, then we recount. We always recount, right? Thank you. Don't forget to smile. I'm hoping you have a good day too. All right, let me clean up. Let me clean up. Right? So let's do it again. Let's do it again. So 5 times 2, right, is 10. We're going to count 1, 2, 3, 4. 5 times 2 is 10, 1 and a 0. And then 5 times 4 is 20. 20, 2 and a 0. We're done. We have no more digits. So we have to recount 8, 1, 2, 3. So 8 times 2, I'm sorry, 1, 2, 3. 1, 2, 3. Because we're done with the 5. Because we're done with the 5, we have to go to the next one. Does that make sense, Eve? So when we're looking at it, 8 times 2 is 16. Add 1, add 6. Yeah. You know, just like how we do, was it 2458? You know how we do bring down the 0? That 0 is a placeholder. So if that 0 is a placeholder, because if you look, right, if you look, we have 20 times 50. Do you need to know the tables to show them? Do you need to know? Yes, you need to know your multiplication fact. You need to know your multiplication facts. uh, you need to know your multiplication fact to be able to do it. I mean, you could do it on the abacus, but it is a little bit not redundant, but tedious. So the kids will end up memorizing anyways. So what I mean is, like, you can tell them to do additive, cumulative addition. So if I did 2 times 2 is 4 plus another 2, um, we have to do that, right? Is 6 plus another 2 is 8 plus another 2 is 10. Does that make sense? So you could tell them this way. I tell my kid, when my kids were learning it and they got so tired and annoyed, they were like, you know what, I'm just going to memorize it. But it helped them understand, they gravitate to certain numbers. Yeah. Ah, yes, I started to type the placeholder, Doug, but I didn't want to get derailed. Yeah. So thank you, Josh, for the hat and the hat and the mustache. Did it work? It didn't work. Okay. So, what happens? Oh, so yeah, just like how we do placeholders. So was it 24, 50, 508? So we do 30, 20, 30, no, 30, and then what? 16 plus 3 is 19. Right? So when we did the 5 and the 4, we bring down this placeholder. It's kind of the same thing. That didn't work. Aw, aw, Josh, thank you so much for all the gifts. I'm sorry. So does that make sense? So this 5, the reason why is because it's actually 50. I don't know if anybody explained that. Like, I didn't know why we had to do the placeholder, but now I understand, because we need to do 50 times 4. 50 times 4 and then 50 times 20. That's why we have this stupid placeholder, because we need to do 50 times 4. I don't know how come they couldn't explain this, right? Ah, thank you so much for all the gifts. Thank you so much for all the gifts. I appreciate that. Thank you, Josh. Thank you. Have a good night. Hopefully I put you into a stupor, into a slumber. That makes sense. I didn't know either, right? Like, yeah, they just told us bring down the 0 and then you'll be fine. And I'm like, well, why? Yeah, that's why. Because you need to do 50. And the difference is you're doing it on piece of paper. So you're using. I, right? Yeah, it's crazy. Like, we're nobody tells us these things. We're just told. But in abacus we don't need to, because if you look, we do 50 times 20. 50 times 20 is 10. 1 and a 0. Do I need to say 1,000? I don't, because why? It already keeps my numbers for me. I was taught to do an X instead of a 0. So that extra didn't make sense. Yeah. So when we're doing this, right, the reason why we cross this out is because we need to reassess. I love your energy. Good. Thank you. I appreciate that. Yeah, it's just funny. Like it's funny when we're taught math in school and there's no actual reason, but I'm starting to understand that why we do certain things is because paper is limitless, right? You can draw anything you want because everything under the sun, right? Everything under the sun, it doesn't matter. The reason why I like Abacus is because there's a constriction. And because now we're restricted to do certain things, we have our formulas. It's just like, guiding children. They know where the boundary is. If you know where the boundary is, I know where to go. If I don't know where to go, then, I'm just going to keep doing whatever. But yeah, glad to have some sort of understanding now. Yeah. Yeah. So when we're looking at it, right, that's why when we do 5 times 2, we don't need to do 50 times 20 because Abacus does it for me. I just need to know 10, 1, and 0. And I can do it again. 50 times 4. 50 times 4 is 200. I add the 200. 200. But Abacus, I don't need to. In the Abacus, I just need to add 20. I just need to remember 2 and a 0. Ooh, whoa, oh. 5 is the tens column. 0 allows us to begin recording to the tens column. Yes, thank you, Miracle. Right? And so then now, because we have a 16, is there enough to add the 1? Right? There is. So I just add the 1 because the abacus helps me see the numbers. When we look, we have 6. And then we have 32. We add the 3, we add the 2. And that's it. Easy, right? Now it's easy because we can see it on the abacus. We can do it again. You want to do it again? We have this one. We'll do that. Okay, we'll do this one. This one is different. Why? Because now it's 3 digits times 1 digit. It's still counting your digits. We still need to count 1, 2, 3, 4. We're still doing distributive property, right? We're not going to do 7 times 85. We're not going to do that. We're going to do 8 times 7. 7 times 8 is 56. 1, 2, 3, 4. Add the 5, add the 6. I'm over here. 56. Okay, thank you, Char. It's getting late. It's starting to get late and I'm starting to feel it. So then what's next? 7 times 5. 7 times 5 is what? 35. Hey, Jose. Thank you, Char. Thank you. Yeah. 30. I add the 3. I add the 5. And then what? 7 times 3 is 21. Thank you, Char. Right? Add my 2. Can I do it? Can I add my 2? Yes, I can add my 2. And then I'm going to add 1. Can I add 1? Yep, add my 1. So what's my final answer? Yeah, I can't believe it. But there's only 10 of us talking, so I'm okay. Right? Does that make sense? So when we look, it's interesting how you build the answers on the marriage from left to right and traditional. Yeah, yeah, it's very interesting. Thank you, Eve. Thank you, Chur. Yes, 5,971. Yep, that's it. Easy, right? Right, Queen? Thank you, Queen. Yeah, thank you, Panda. We can do it again. You want to do it again? It's because I curated all these questions. Now we're going to do it all. Because everybody's always asking multiplication. I need to curate the questions. And then I had this thing and I was like, oh my God, this is the greatest thing next to sliced bread. It's going to be so easy to curate all my questions now. Okay, so thank you so much for teaching us. This is way super interesting. Oh yeah, thank you, Jamie. Yeah, not a problem, not a problem. Oh yeah, you're welcome. You're welcome. Have a good night. If you're leaving, have a good night. I hope to see you in my next live. But yeah, I'm really quite excited for my next books. I'm going to start doing some multiplication, and I'm like, oh my god, this is what I'm going to do. Anyways, so if you notice, we're doing simple, right? What does that mean? Simple. These are my nights winding down life. I know now how to use the abacus. Oh yeah, you're welcome, Star. But yeah, see, the difference is what? The difference is what? The difference is now we're not using any formulas, right? Midnight Mathers, Panda. That's funny. I'm so excited when I can watch these before I go to bed. They're so silly. I honestly I enjoy, these late nights because it's just easier to, I don't know. Or you know what? I take that back. I'm blessed to have a very good community. I'm very blessed to have a good community. Most people that come over and they're interested, they're really interested. Practicing on my 13 column, I mean, night is best. All right, so we can do another one. Let's do another one, yeah? No, you guys are so awesome. I really do enjoy all the comments and the questions, and it makes all sense, right? And it's not like everybody will get it. It just takes time. It just depends on what time because everybody's unfamiliar with abacus. Though I cannot be unfamiliar. I've been doing abacus for 20 years. But, you guys are just learning abacus and understanding the numbers and understanding the columns. It takes time. I mean, I don't remember anymore, but when I was doing it, it took me a while to understand why we're using it. So, what are these before? Hey, Austrian. Thank you, Adriana. So, what are we going to do? We can do another one. Should we do a review? Should we do a review? Let's do a review for those people that just came in. So let's do a review on the abacus and how to count the abacus, right? Mine sits on my desk and I use it instead of a calculator. Oh, that's really cool, Vic. I learn a little every month. Yeah, right? I do enjoy this. I do enjoy this. Thank you guys for entertaining me. All right. So when we're reading, we do one, two, three, four. Because all these beads are touching, right? These are all counted. And then this is the horizontal bar. The horizontal bar tracks our numbers. Because the horizontal bar tracks our numbers, anytime the beads are touching the horizontal bar, that's what it is. So when I do this, this is five. The top bead will always be five. It doesn't matter that it's the color. So if I change it out, if you happen to be colorblind, there's no excuse. Oh yeah, that was the funny thing. Somebody's like, "Oh yeah, I'm colorblind. I don't know how to read the abacus." Oh yeah, yeah. Well, what about that? What do you think of them apples? You can be colorblind and still use the abacus. So we're going to count again. One, two, three, four. Then the top beat, there's a top beat. When I add the top beat to the horizontal bar, this is what we call five. So we have five, six, seven, eight, nine. So then after nine, we have 10. 10 is this. 10 just means that we're going to go to the next column over. When we go to the next column over, now we have 10. We can count 20, 30, 40. 50 looks very familiar, doesn't it? 50. This is 55, is different than 10. That's 10. 1 and a 0. 2 and a 0. 3 and a 0. 4 and a 0. Do your kids know you? My kids know that I'm on TikTok, yes, and no, they think I'm very annoying. They're sometimes they'll come in and then they're like, "Oh shoot, I'm not supposed to be here," and they leave because they think it's really boring. I know all this, but they do help me fine tune my workbooks a little bit. So yeah, they're helpful when they're helpful, but they're not. They don't like the abacus like I do. I just wish I had more. I wish they were able to use my worksheets, but they were really young and I didn't have a lot of time. But now since they're a lot older, I have more time to do it. Oh yeah, thank you, miracles. Yes. So here's my question. I'm going to count again. So I'm going to count my digits. When I count my digits, I want to count 1, 2, 3. Why? The reason why we want to know where our digit sits is because I want to know where our answer lies. So what we're going to do is we're going to do 9 times 8. 9 times 8. 9 times 8 is what? What is 9 times 8? Yes, thank you. Okay, good. Hey, Batman, thank you. Thank you, Eve. Yes, 72. So I have my 7, right? And I had my 2. And then what do I do? Then I do 8 times 3. Thank you, Coco. So 8 times 3 is equal to what? 24? Thank you. Thank you, Batman. 24. So I have my 2. Do I have enough? I can do it. I add my 2 and then I add my 4. Thank you, Coco. There's my 4. So my final answer is not 96, not 96, 744. Vero's so funny, right? So, well, I don't know what 96 is, but it's not 96. Because how do we know? It's 7, right? 5, 6, 7, and then 4. 1, 2, 3, 4, and 1, 2, 3, 4. Yeah. So it's 744 is the answer. Multiplication is interesting. It is very interesting, but you still need to know your one, you need to know your multiplication facts, and two, you still need to know your how to make a 5 and how to make a 10. You still need to know all of that. We can do another one. We can do another one. And I think that would be my last one. Yeah. And that means I gotta find new numbers, new questions. All right. Yeah. Okay. This one. We'll do this one. My God, this one is so crazy. No, it's not. No, it's not. I was able to find my numbers. What? Okay, you know what? I'm going to start asking you guys questions. What is my starting point? Where do I go? Thank you, Astrid, for the heart me. Where do I go? What do I do? What am I doing? What is the first thing I need to do? Thousands. Yes. One, two, three, four. How do I know? One, two, three, four. Thank you. So now we have to count. Yes, thank you. We have to count. Now, yes, you're right. Thank you, Queen. No, not 4 times 5. No, 5 times 7. Yeah. We go the outside first. It's a different way of thinking. Yeah, it is a different way of thinking. And it takes time, right? 7 times 5 is 35. 35. Good. And then what's my next question? What's my next question? Yes. What? How did you get that? Right? 4 times 5. Yeah. Then we get 4 times 5 is equal to 20. Thank you. Right? Thank you. Right? So we have 22 and a 0. Wait, how is that 35 down there? Hold on just a second, Skyzer. So what's our next question? What do we do? What do we do? 5 times 7. Yes, we did 5 times 7. So now we're at 37,000. It's 3,700. Yes, thank you. Thank you, Miracles. So we recount, right? We recount it. 1, because we're done with that. 1, 2, 3. So 1, 2, 3. We're over here. Thank you. So then we're going to do 4 times 7. Thank you. Vic. 4 times 7 is 28. Yes, thank you. 20. Is there enough? Yes. Add the 2, add the 8. 5, 6, 7, 8. And then what do we do next? What's next? 4 times 7 is equal to 28. What's next? What's our last question? Thank you. 4 times 4. 4 times 4 is equal to what? Oh, sorry. Sorry. 4 times 4 is equal to what? Thank you guys. So, yes, 16. Add 1, add 6. Yep. So, my final answer, what's my final answer? I don't even, you don't even know me. Hello. You don't even know me. Welcome. Thank you. 3,996. Yes. Yes. We didn't even do any problems where we have to make. Yes. I know. Because I was able to curate those questions, and that's what makes it fantastic. But that's what makes it fantastic, right? Now you know. But when we start getting into it more, then we can go into the adding of the 5 and adding of the 10. But I was trying to make it as easy and interesting as possible, right? So, what's that's what makes it confusing. Hi, Caitlin. So when we're looking, right, we can count our numbers, right? It's easy because we want to just see that it's there. So we're going to count. So 35, somebody asked, well, why is this 35? Well, this is 35 because when we counted our place value, we know where we're going to put, right? That makes sense progression wise. Yeah. See, that was the thing I was going to do is I was going to create a workbook. You start from simple, but see, that's because you've been part of my lives, right? You know the progression. You start with simple, then we do adding of the 5, and then we do adding of the 10. Hello, Annette. Welcome back, right? And so that was the one thing. Like I can't just give you if you just start off learning multiplication, I can't just give you everything under the sun. And that's why I think in mainstream math, that's where it's a disadvantage because they just give you under everything under the sun, whereas it should be systematic. You understand how to add, right? What we just did is we understand to add 35. We add the 30, we add the 5. What we're doing is we're understanding if we have enough beads. Then after that, then the next progression would be how to make a 5. And then after that, how to make a 10. And I think there should be more of a progression when we start looking at numbers. Numbers have a pattern. Abacus shows that there's patterns, but in mainstream math, we don't know what these patterns are. It's still very aloof. They talk about, oh, skip counting and all this and that. It's like, yeah, you can do skip counting, but it is a little bit more difficult. Oh, thank you, Queen. Have a good night. Had fun learning. Oh, good. I'm happy you had fun. When you do 11 times 11, how do you get, or instead of, we're multiplying 70 times. Yes, thank you, Miracle. Okay, so tiny abode. When we do 1 times 1, right, we still need to count it. So when we're counting it 1, 2, 3, 4, we still do 1, 2, 3, 4, right? But when we're doing it, 1 times 1 is a single digit. So I go back one column, I add the 1. When I do it again, 1 times 1 is 1, 1's a single digit, I add the 1. That's where we did, right? We did this. So we do it again. Now I got to do 3. 1, 2, 3. 1, 2, 3. I'm over here. 1 times 1 is 1. 1's a single digit. Go back one column, I add the 2. 1 times 1 is equal to 1. 1's a single digit. I go back one column, I add the 2. Did that make sense, Tiny Abode? So that's why, because what we're doing is we're adding our numbers. We're adding 11 and then a 1. So it's actually, when we're looking at it, it's not 1, 1, 1, 1. It's it's uh, 10 times 10. And then it's 10 times 1. And then it's 1 times 10. And then it's 1 times 1. That's why. You treat it like 0, 1. Yes, we every time it's a single digit, we treat it as a double digit. Yeah. So if it's a 0, 1, 0, 2, 0, 3, 0, 4, just like we do time. When we do time, right? When we do time, we like what time is it? 11:07, right? Just like we do time. My head's in the way. Just like we do time, we still do it in double digit. We still do double digits when we do 2 digit month, right? 2 digit month means May, right? 05 is May, and then I don't know, 08/25. That's the date. We still use this. So having a single digit is not foreign to us. It is not unfamiliar, if that makes sense. But that's a good question too. But also understand, abacus, we don't need to memorize what 11 times 11 is. We just do distributive property on it, and then we're golden. Yeah? Oh, yeah. That's a really good question. That was one of the things, like, the kids just don't, like, it's fun. Like, I think it's fun. But yeah, when we look at it, we want to look at it like this. So. But yeah, and it's just like anytime we do single digit, it's always going to be a zero. Usually, it's going to be a zero and a one. It's always going to be a zero and a one. Abacus, and it's interesting how abacus really um, uses that to its advantage. All right, how are we doing? Oh, okay. But that was a very good question. Thank you for that question. Okay. If there's no other questions, I would like to end the live. It is getting late. It is almost midnight for me, and I'm sure it's like 3 o'clock, 3 in the morning for everybody. Hello, Jeremy. Thank you, Deceptive. I came too late. Oh, I'm sorry. Is it you? We could do a review. We could do a review. If you don't know how to read the abacus, here's a review. This is one. This is two. This is three. This is four. This is a wonderful nighttime surprise. No review. Okay. Thank you, Jeremy. I appreciate that. Well, if you want to follow me, I will go on live pretty often. I think I'll be alive tomorrow morning. Tomorrow is Wednesday. Yeah, and I don't think I'll go. I did follow. Oh, thank you, Jeremy. I appreciate that. That's a wonderful surprise. Yeah, thank you, Vic. I'm so happy. Have a good night. Have a good night, Joel. Pick your brain later. Hooah. Yeah, of course. Of course. Anything about abacus or anything about math, I don't know calculus, that's above my pay grade, but like anything abacus, arithmetic, and how school teaches arithmetic. Yeah, I really do enjoy all of that. Great class. The multiplication makes a lot more sense now. Yeah, see, Eve, because they're curated, right? I didn't confuse you with all of the adding of the five and adding of the 10, right? Thank you, Char. No, thank you. Go rest. I'm only on level 17. Okay. But yeah, that's what I'm saying. Like, I think when the questions are curated, it's easier, right? It's easier to understand when you don't have to mess around with all the other questions. So that's why curating the questions is very important. It's very important in I feel like in abacus, just because there's a lot going on. Yeah, the curating worked. Yeah. So depending on my next one, and depending on how fast the class is, we might be able to go to multiplication with adding five, right? And then the next one would be multiplication with adding tens, and then again it would be multiplication. But then because I'm doing this, because I'm doing this now, I can curate my workbooks, and now I can have workbooks in separate sections. So you'll have a workbook with multiplication, but every chapter will have specific phases: simple, fives, and then tens, and then mixes. And then depending on and then I don't think it's going to matter on the amount of digits, but that's the plan for the multiplication. Yeah. So that's exciting. Oh, thank you, Char. Education, not age. Oh, bye. Your chief. I need to catch up since 1994. Archives since I need to catch up since I'm not sure what that means, Jeremy. Math, 1994. Brilliant. Thank you. A usual? All right. Uh, I need seventh grade math. I don't do seventh grade math. I go up to division and we can do decimals, but that's about it. Oh, I failed since then. Oh, I see. It's yeah. If you go through the abacus, if you're really interested, you go through abacus. It's really quite interesting and easy. There's a lot of people that have gone through a lot of my lives, and they really enjoy it. Those that stick around really enjoy it, and I appreciate that. Yeah, but yeah, I think the next one would be the add the fives, and then I can start carrying the division, which would be good too. Yeah, I'm so seriously interested. Yeah, okay. That's great. Well, let's do a little review and then the next time we can talk about it. So here's one. Anytime we have the beads touching the horizontal bar, we have one, two, three, four, and then five. The top bead will always be five. Don't feel dumb. This is not a, this is the fun grade. This is the fun grade. So this is five, right? All the top bead is five. We have five, five. This is 55, not 10. 10 looks like this. That's 10. So we have 5, 6, 7, 5, 6, 7, and then 8. 5, 6, 7, 8, and then 9. 5, 6, 7, 8, 9. 10 looks like this. 10. How do I know? Because every column is a place value. So we have our columns, our ones, our tens, our hundreds, our thousands, our 10,000s. When we look, this is 10. So now we can count by 20s. I'm sorry, we can count by tens. 10, 20, 30, 40, 50, 60, 70, 80, 90. After 90, we can do 100. 100. Okay, that's my time. All right. I will hopefully, Jeremy, I'll see you in the next live. Thank you for stopping by. Thank you for stopping by. Right. Have a good night, everybody. Thank you guys so much for joining. Not Ozzy. Ozzy. Not Ozzy, like not Ozzy Osbourne. Oh, okay. Thank you again for the follow. Thank you again for joining. I will see everybody else in the next live. Have a good night, everybody. Thank you. Oh, my God.